we are going to use the X and Y planes for analysis. How is the stress distribution over the plane surfaces? Not inside, like last time we did transverse, means across the cross section. Before that, axially, when the member is loaded axially, longitudinal, parallel to the longitudinal direction, what are the responses of the member that we saw in the beginning, and then strain, and then relationship, followed by transverse loading, which is across. Now it is on the surface, on the plane, on the body of the structure. How is the distribution? It's very important to handle the or monitor the equipment. It may be equipment, machine, structure, or of any movable or stable structures, right? In that we will find principal planes and principal stresses. Sometimes it will be asking for both, including the some other, the planes can be found by angle of deviation, so we'll also find the angle, right? Let me go by the recording. I share with you the recording. Okay, all of you know that the stress acting at a point, if it is uniformly distributed and then it's balanced, there is no problem. If not balanced, you will end up with failures. Failures may be due to the type of loading or type of support or workmanship, anything of that type, right? And here the transformation, the meaning is changes. There is a change in stress. There is a change in stress, especially when the object is in moving, when the object is in rotation, like cranes in rotation, the chances of failures are more. You have to analyze properly and then monitor properly when the equipment is in operation. That is why this subject is coming in. It is not always static, it is in dynamic. Come on. The stresses, both two types of stresses you studied, normal stress and shear stress. Both stresses, right? Normal stress is just a vertical loading, whether it is a perpendicular to the longitudinal axis or along the longitudinal axis. Both will create a kind of a axial loading, will create a kind of a normal stresses. But when it is at some angle, the loading is at some angle, or the object is inclined, object is oblique, automatically it is subjected to a shearing type of loading, and the stress produced is called shearing stress or shear stress. Okay, and this shear stress, because it is acting at an angle, it will keep changing if the angle is changing, right? Correspondingly, the axial load will also, the actual normal stress also will change. I will show some animation, interesting one. You cannot imagine whether it is changing or not, but by animation, the borrowed animation can help you to understand how the changes in stresses are taking place in a member. By taking a component or an element of the member, we will see. Right. The plane, the assembling of aeroplane or any aircraft have many equipments and accessories, right? Equipment and accessories start from manufacturing, like assembling, until its operation. Even during its operation, there is a need for proper checking of its fittings, the stress distribution, concentration points, failure points, all should be thoroughly understood, studied, so that if at all anything happen, you can fix it. But machine and materials, machine and instrumentation, everything will be taken care of by mechanical engineer. But when it comes to structure, the same problem will also exist in solids like structures. Similar problems, similar stress concentration problem, similar failure problem will also be addressed in structures where you have different materials, wood. In exam, I may ask any type of material, steel or wood or aluminum, but I will give you properties. If it is, you have to use properties, I will give you properties. With that, you must know how the different materials are behaving, right? Any type of material used in the construction, it may be a truss, it may be a building, it may be any facility. In all, in addition to designing, like site engineer, if you go to site, you just quickly work out how much load acting on it, how much bending, how much is stress, then you immediately give the number of rods, size of the rods, you complete your building design. But apart from this, the building is stable, right? So no problem. But in the same case, if it is a moving thing, right? It's a moving object, moving construction, like hanging bridge. Hanging bridge always having a shaking, right? It's in motion. And then if it is what do you call door? Well, not door. Gates constructed at the harbor, right? It's also a structure, but it's a gate in operation always. When the ship is coming in, it should open and then keep it closed. It is standing against the water force and also the wind, moreover, its own weight. All these effects have to be borne and supported by these gates at the harbor in position, in operation. In that case, analysis will be complex. You have to use software to analyze the vulnerable points. This section will have transformation of plane stresses, principal stresses, maximum stress, and so on. Especially, I will ask you to do the Mohr circle. Mohr circles are the famous one. The name is given after the scientist Mohr. He has developed a circle, and then the circle has many parameters for you to understand and generate the design variables from there. I will explain to you and how to construct, what are the parameters in it. Your job is to understand the parameters. You should know how to read the drawing. As an engineer, when you go for co-op next time, you should know how to read the drawing. That is one of the skills you are getting during your studies itself. What are the notations there? What is the phi notation? What is the dotted line saying? Dash dot line saying? What is the hidden line saying? All these skills you have to develop during your studies itself. Like that, you must know what are the parameters inside the Mohr circle and importance of the Mohr circle and the results that you can obtain from Mohr circle. Let's go. In the examination point of view, if you think, I will ask you to construct the Mohr circle, and there are two types of stresses I already initiated, normal stress and shear stress. This normal, I will ask in this time, I will ask you to plot only for normal stress. Shear stress, I am sure you will repeat the same Mohr circle in geotechnical engineering. You do the shear in geotechnical engineering because they are the one designing for shear, most important for geotechnical engineer. Because the subject is introduced now, I don't want to dump with too many information. Study this thoroughly, the factors inside, the importance of this diagram, applications of this circle, advantage and disadvantage. With that, you are able to construct and produce your principal planes, principal stresses for normal stresses only, not for shearing. But you know where it is. I will teach you where it is and how it is. Don't worry. Now, the most general state of stress at a point may be represented by six components: 3 normal and 3 shear stresses. Okay, any body when it is subjected to loading, it will undergo these 2. But whichever is significant, it depends on whether it's just axial loading, whether the member is stable, static, whether it's loading is at some angle, oblique angle, at certain angle, or object itself is inclined, right? Maybe inclined door, inclined window, inclined wall, right? Then these objects will be subjected to shearing type of stresses or respond in the way of producing, by way of producing shear stress developed in the element. Okay, let's give the notations. The notation I follow as it is: sigma x, sigma y, sigma z, all normal, and this is tau is treated as shear stress. This is requiring a plane because it is a 2-dimensional effect. It is a 2-dimensional effect. I will explain later why is 2-dimensional. For now, shearing is happening with a plane. So xy, yz, and zx. It's all written here. When you take this face, when you take a cube, a cut portion of a beam, it may be a small portion inside a beam. Elemental area, you can take this as an elemental area of a beam. I-beam, rectangular beam, triangular beam, T-beam, anything of that kind. Take a small elemental cut section inside, right? And then you can see how this is subjected to, or how many stresses are existing. When you take this face, it will have one normal perpendicular to the face, one normal, and then two along the plane or on the plane of the face. This is a plane, right? This is a plane. Plane means just imagine floor. The circuit is on the floor, right? The system is on the floor. The lines are on the floor. That is plane. It's on the floor. These two guys are on the floor. This guy is perpendicular to the floor. So these tau xy, zy and tau zx are on the plane. These are the shear stresses and a normal stress. So any element will be subjected to these three. And this side, similar to that, on the plane is the shear. Perpendicular to the plane is normal. Depending on the direction, you can name it. This is along parallel to the z direction, z. This is parallel to the x direction, x. Same goes here. Parallel to the y direction, perpendicular to the plane, normal, sigma. And this one is on the plane. It's always on the plane, that you remember that way. On the plane is the shear stress. And between which axis it is acting, then it is called YZ and YX. Between this and between this face. Okay. Now, if this is the case, we have no problem. Just no change. It will always be subjected to like 50 Newton per meter square. Stress meter square. And this one always 10. If this is 60, always 60, 20, 20. And then this one 80, 10, 10 or 15, always the same. If no other changes taking place. What if it is tilted? The object is tilted. Then automatically, if this is 20 here, automatically change to 20 plus. Because when it reaches 90, only it will become maximum. So 20 plus, also plus. And this side is minus because it's going to the negative. Later I will give you the sign convention for drawing. When you go to the drawing side, you must remember this. It is totally different from what you did in the transverse loading. Transverse loading, shear force upward is positive, downward negative. And then moment you take clockwise positive, anti-clockwise negative. Here it is totally different. You have to remember it is in this subject, this content, this chapter is taxing your remembrance. You must remember when you do the Morse circle because it is defined by Morse. He has set the rule. He has set the sign convention. You need to remember. There is a sign convention for the stresses and the plotting. You have to follow. Stresses and tensile, compression. Tension is taken positive, compression negative, and then upward, downward. I will explain when it goes to Morse circle. But forget about axis system there. I just understand where positive, where is negative. Because again, it is differing from the axis system, normal axis system, normal graphing system. Although it looks like a graphical representation, but doesn't follow a graphical representation in Morse circle. Right? Same state of stress is represented by different set of components if axes are rotated. Different set of components. Yeah. This paragraph says, this chapter is concerned. Okay. How stress are transformed. Okay. Just keep in the meaning of this paragraph is, it says that initially it is subject to these many stresses, right? Three components, right? 2 shear, 1 normal, 2 shear, 1 normal, 2 shear, 1. Same setup is here. Even if you rotate it, same setup. It is still subjected to 2 shear and 1 normal, 2 shear and 1 normal, 2 shear and 1 normal. But the value will be changing. But it is not balancing for information. I also try to wondering to see whether it's balancing or not. No, it's not balancing. It is changing. The values are changing. And then engineers are more concerned about where it is maximum, where it is minimum, where it is the average, where is the ideal condition for its design. That is where this Morse circles will be helping you. I repeat, when the object is like this, same constant value acting on it. When it is rotated, same components, but the values are changing from the given value is changing to maxima and then minima, and then ideal value, maybe in between ideal value or somewhere it is here is reaching when it is rotated. In one cycle of rotation, you will have a few factors like maximum, minimum, average, and the range. All these things are observed when a member is in rotation. That is why the stress names are given as principal stresses. Sometimes maximum, sometimes minimum, sometimes zero, sometimes ideal for design. So by analyzing all these types of stresses, you will come out with the ideal value, which is to be designed for the member. Wherever it is necessary to go for maximum, you can use maximum. Minima, you can use minimum. But you should know where the location of maximum value, where is the location of minimum value, at what angle this particular member of this property, aluminium, timber, bamboo, right? It has its own property. At what point, at what angle of rotation, it shows a particular stress value, either maxima or minima or zero. That is what we are going to analyze. Plane stress. State of stress in which two phases of the, it's all for your understanding, and this chapter and next chapter, I don't ask you objective question, but try to understand the meaning. State of stress in which two phases of cubic element are free of stress. For illustrated example, the state of stress is defined as this. Yeah. Because it's subjected to axial loading. Right. Where is it? Plane stress. Okay, I use the same. This one. This is easy to understand. Come on. Now it's about the plane stresses. Start with plane stresses. Where the plane stresses acting, right? If you see here, state of plane stress occurs in a thin plane subjected to forces acting in the middle plane of the plate. That means axially. When the member is loaded axially and it is not rotating, it is not at some angle or inclined or twisted, right? Then you can say it is subjected to only plane stresses or normal stresses only. You see here, just like this, like this type of stresses, like this type of stresses, and this one, and this one, because it is subjected to either in this ends or this ends. Okay, either this ends or one moment. F4, F2. I don't know why they confuse like this. Just I draw for you. When the member is like this, it is subjected to loading like this, axially, right? Then it will have only plane stresses. It will no longer have as the what do you call the shear stresses. On the other hand, if the member is inclined like this, and is subjected to loading like this, it will have shear. Okay, this you already studied, right? You already studied. So the same meaning, if the member is subjected to axial loading, like if the member is like this and is subjected to loading like this, then it will have only plane stresses. It will not have shear stresses. That is the meaning of this slide. And then another one for a member like this fixed to a wall, right? A beam fixed to a wall, maybe a circular beam fixed to a wall, or state of plane stress also occurs on a free surface of the structural element or a machine component, that is at any point of the surface not subjected to an external force. So it's due to its own self-weight, although the loading is not acting, due to its own self-weight, it may be subjected to, if you want to analyze for the plane, it will be horizontal and vertical. Okay, you can analyze the resultant force in horizontal and vertical direction. Now, there is a transformation, there is a change if it is at an angle. Consider the conditions for equilibrium of a prismatic element with faces perpendicular to x, y, and x dash axes. Right? Initially, the axis is like this, stable one, like this, no change in the angle. But suddenly, if it is changing to an angle, right? Changing at an angle, automatically the plane, first of all, the plane is changed to x dash y dash on the surface, and then it is at an angle, and then components are lying on this plane. Okay, components are lying on this plane, or it is creating a shearing stress on this direction, normal stress in this direction. If you want to analyze in one direction, you just do this only. Two direction, you need to consider y direction as well. Okay, I'm not going to ask you to derive this equation. These are the equations. This is the equations of transformation. If you one method is, if you want to know how much is the value change due to this angle, right, producing an angle, or due to this tilting of this member from horizontal to at an angle of theta, how much is the stress value changes, you may use this equation. This is called equation of transformation, right? These equations will give you, I don't know why they didn't put no, not this, the theta should be out. This one. Derived from here, but don't bother about the derivation. Ultimately, you have the equation, transformation of equations like this. If there is a change, automatically the values of stress on the member will be changing and can be found out by using these equations. Two types of normal stresses and on the plane. For example, if you take x and y only, you will have these two normal stresses, and then on the plane between x and y, you will have one shear. So the values of this shear and normal stresses can be obtained by using this equation and then properly substituting the theta value. The same equation can be used if the theta is changing, theta 20, 40, 90. And when you keep on changing the theta value, at one point you will reach the maximum, at one point you will reach zero, at one point you will reach minimum. So you can make use of these equations, equations for finding the values of the different stresses produced in the member, either by its own weight or by loading or by motion or in operation. You can use it. This is one way of finding changes in plane stresses or transformation of plane stresses. One. Second method is using Mohr circle. I give you some introduction only. I'm not going to draw because I want to keep a paper and draw it myself. Take a video of that one. It takes time. I don't want to spend the class time for that. And let me give you the reading and the meaning of for each and every term here. Then we go for it. Your questions will be like this. You pass in the exam like this. You are given a plane, then you do the circle, construction of the circle. Okay. That part I will explain by whiteboard. Now let me give you the information only. So number one is using this equation. Number one, finish. The job is done. I have found out how much is transformed value of the stresses in my plane when it is rotated at an angle or in operation at an angle. All these things can be found. Another thing, by using Mohr circle. By using Mohr circle also, you can find the value of changes in stresses acting in different direction. Right. The previous equations are combined yield parametric equations of a circle. I just give you the theoretical point of view. Later you may have to draw like one such for a given condition. The plane surfaces or the plane stresses, value of plane stresses given to you. It's very simple only if you understand. The outcome expected from this study is to draw the construct. You want to construct or sketch. You really have to sketch. If you use pencil, use HP pencil or dark pencil. If you are afraid they may make mistake, you have to use dark pencil to draw the circle. I'm sure you will do more work in geotechnical engineering. They are the one using more often, because in solid mechanics or theory of structures, shear is already covered by our shearing the ribs and the reinforcements. With that, we don't. It's a minor compared to bending. Shear is less. Buckling is most important for structural engineer. For geotechnical engineers, shearing is important, right? That's why they use this Mohr circle more often than structural engineering. I repeat once again, the changes in the value, the transformed stresses for a given condition of loading can be found out by using this. So you need to plot like this. This is the axis, you just keep the axis like this. Don't worry, positive, negative will be totally different. Forget about your graph, normal graph system. I request you to forget about normal graphing system. But I still keep this as x and y. This is x and this is y, and this is 0. Okay. And then what else you need to know? Later we will get the points. We have to mark the points and then join the points to rotate to get the circle. And then this is minimum, this is maximum, this is average, radius, right? This is radius. And then what else? What else you have to say? Okay, I will do the plotting, then you may understand more. But you are going to do a circle for the given points, x and y, the points of shear stress and normal stress. See, the coordinates are normal stress and shear stress. These values are changing, hence you need to find out the value. The coordinate of these two will be given to start with. Once you plot this on this plane, you will combine, you will make a circle to find minimum. See, from 0 is minimum, is maximum. From 0 is very far, right? The value. The normal stress is very high. At the same time, these minimum, maximum all happening when shear stress is 0. See, this is shear stress is 0. Okay, I will explain in more detail with the example 1 and by plotting it. For now, just understand this is in the form of plotting circle. It will have maximum, minimum, x and y, and between normal stress and shear stress. These are the things you should know. Let me explain this part. Analysis next semester, IR Lee Jing Jai, he is going to teach theory of structure. He will use Revit for his analysis, deflection, finding deflection on frames, members. You start using right now. Take it sportively. Whenever you feel boring, just go into Revit or BIM software. It's a BIM. It's also available as a tool in BIM software. Recently, they captured this one. I mean, they joined. Last time, a few years back, Revit is different. Now BIM is inside. Revit is inside BIM. If you get along with the BIM software, also you can find this add-on tool. Open the Revit software. Run the example once, the sample once. You know how to analyze. You can appreciate how this conveniently it is analyzed. You can even test your calculations using the software. Can you do it? If not now, at least after exam, you try. Okay, take interest, because nowadays software is ruling. With software only you can analyze the complex problem. All of you must have gone through Revit. One software, I'm just telling you one software, Revit only, which is available in our library. You go, if you have any survey student, friend, teacher, make a request, and then use the lab, start. The time you can learn. After you leave, you don't have time. If you go for any certificate course, if you get the certificate also, it's a good point for improving your profile.
An example of stress transformation for the stress state described by the stress element shown here.
All of you note this value. This is 20. This is 10. Hear me? Can you hear me? Yeah. So far you have gone through the theoretical point of view in analyzing the stresses on the plane. Now this video will explain you how the animation is taking place, how the values are changing when it is in motion. Just watch through the video. This is 7. Mark these numbers. Totally 37. Okay. And see how in total and individually it is going to vary when it is rotated.
As we rotate the stress element, the normal and shear stress components will vary.
What is happening at 90?
Rotate the stress element. The normal and shear stress components will vary.
Okay, at 90, you see here 90. There is a significant change when it is coming to 90 and 180 and then other value. You see, mark the degree.
Once we have rotated the stress element by 180 degrees, we will return to the configuration we started with. It is important to remember that the actual stress state within the large body is not changing when we rotate our stress element. We are just rotating the axes of the coordinate system we are using to visualize the stresses at a single location. We can observe that for certain angles, the normal stress will reach maximum and minimum values, and that these maximum and minimum values are separated by an angle of 90 degrees. This means that when we rotate our stress element such that we have the maximum normal stress on the x face of our element, we always have the minimum normal stress on the y face. Another interesting observation is that when the normal stresses are at their maximum or minimum values, the shear stresses are zero. These faces on which the shear stresses are zero are called the principal planes, and the corresponding maximum or minimum normal stresses acting on these planes are known as the principal stresses. Principal stresses are very important, so let's recap. They are the corresponding maximum or minimum.
I stop here. See here, this plane is called as principal plane because it's going to give you the principal stresses, minimum and maximum. Minimum principal stress, maximum principal stress. Okay.
Minimum normal stresses acting on these planes are known as the principal stresses. Principal stresses are very important, so let's recap. They are the maximum and minimum normal stresses acting on our stress element. They always occur when the stress element is rotated such that the shear stresses are zero, as shown here. We denote the maximum and minimum principal stresses using the symbols sigma 1 and sigma 2 respectively. The rotation angle which gives us the principal stresses is denoted using the symbol theta p. Because it is the maximum normal stress at the location of our stress element, being able to calculate sigma 1 can be important for predicting failure.
You understand? So this is showing just a normal distribution of the stresses in normal direction and on the plane, right? The shear and normal are shown as usual. You calculated in chapter 1, 2, 3. This is the value you are calculating, right? And then when it is rotated or in motion, you will have a changes in value reaching to a maxima or minima. These are the things governing any design or helpful for predicting the failure. That is why we have to undergo this study and learn how to draw more circle to find out these unknowns, minima and maxima. Okay, I maybe this video you can see later. Continue.
Moore's circle is a graphical method.
Okay, all of you know that the stress acting at a point, if it is uniformly distributed and do you have any question on the slides and the video shown just now? Introduction about how are the principal stresses existing and how are you going to solve. There are two methods. One is analytical method using equations that are derived. Second method is graphical. We already completed the graphical explanation just now through the video. Do you have any question? If not, we move on to plotting the graph. Okay. Right. Any question? In the video that just now is shown, can you imagine how the values are changing whenever it is rotated, the object is rotated, the corresponding changes in the stresses, right? No question. No response. I take it as no question. Let me move on to. Before I move on to drawing the Moore circle, it's good you prepare with the graph paper, pencil, draft pencil. Can you arrange it? Can you able to do it now? Okay, I give you 2 minutes. Meanwhile, I will also give you, I hope you can arrange it, otherwise we'll do it in the next class. Because while I plot it, it's good you also plot it together. Otherwise, it will be confusing later on. Okay, can you get ready with the graph or how? Can we do it today? Otherwise, let me continue with them. It's better you prepare it, otherwise we do it in the next class. Let me continue with the assignment briefing, right? And then I go for more circle plotting, right? Because it's better you do it together, otherwise you'll have a lot of questions. Let me continue with the another assessment for you. I share to you this assignment. One moment. Let us take a short break to know about your assessments. It's here, your module outline. Okay, you have these 4 assessments, right? Test 1, and the results I will post to you by Monday, your 10%, right? You have been given 10 questions, 10%. I will post to you by Monday. You can check on Monday. Before Monday, you can check by morning on Monday. And then test 2, 20%, full of calculations I'm going to give on 3rd and 4th chapter. Final exam 50, assignment. Because you are doing online, it's good you do by presentation. I do not know whether you really do and how much you learn. All these things can be understood and clear when it is presented. Right, it is for 20%. I'm now going to give you this assignment brief. How are you going to do? How are you going to submit? All right. If you have any suggestion, correction, please do it. If not today, you can also inform me either personal message or in the chat box if you want any kind of corrections or amendment required in the brief. Let me think and do it for you. Now, this assignment brief, let me open the assignment brief. Is for 20% covering first three outcome. What is it? Yeah, learning outcome 1, 2, 3. That means the 3 chapters. Number 1 is you'll be having all this stress strain, and then the torsion, and also relations between stress strain, including the bending stresses, shear force, bending moment diagram, up to the shear force bending moment diagram, and then bending stresses, excluding today's portion. Up to last class, you will be having test 2, right? And the assignment will cover up to 1, 2, 3 again. 1, 2, 3. Because I have to give you by today for having enough time for you to prepare. That's why I'm giving on only these 3 CLO, not on the 4 and 5. You'll have 4 and 5 only for your examination assessment. Now the assignment follow only these 3 CLO. Let me open the assignment brief for you. Stop me if you have any question, right? Yes, yeah. Right. Can you hear me? Assignment brief, only one assignment you have. Stress analysis and design, individual, oral presentation on stress analysis and design, covering these 3 CLOs. Deadline for submission, I am giving 2 weeks time. By week 13, you are submitting. Now is week 10. Take 11 and 12. By beginning of 13, Monday, you will submit the assignment. How is it? You please write all these things, and it is evaluated for 20%. And the evaluation is like this. It's a calculation. Your calculation is distributed among these type of criteria. You must clearly mention the strategy of the problem, modeling involved. Modeling means all the calculations, equations that you're going to use, principles, law, whatever it is. It's not a big thing. Whatever I have given in the slides, you can produce that one. Good enough. Some people, you miss out the equation, you are not aware of what is the definition, what is the notations used. That's why it is mandatory that you explicitly mention all the equations, meaning that is evaluable by 5%. And then analyze. Apply these and analyze for the given question. Finally, after analysis, the analysis may be of 2 types now, because your what you call your course outline is C4 and C5, including C5. The C5 is evaluate, right? And the evaluation is done by this reflect, the component called reflect. Once you finish your question, you need to reflect on the answer. What if the value is changing? What if increasing, decreasing? Why is this difference? What is the relationship between the parameters you determine? Something like that you have to, about its geometry or about its access analysis or about its relationship between the parameters. Like this you have to talk about. That is what reflect means. And then think, finally, you may have an alternate answer for this also, suggestion that you can come out with 3%. That is evaluated for 3%. The question, let me give the question, then come back to the instruction. Like I give you the open out the suspense first, then I give you explanation. The questions are very simple. The questions are 5 questions are given. I want to add if you want. I have given only 5 questions here for the first 3 CLO: stress, strain, torsion, and then this one is on design, right? Selection of member, and again repeated for stresses, right? Like this similar question we worked out in the class. Just follow the same procedure. If I stuck anywhere, you can always ask me, but put some effort. Don't come with a blank paper. This is again a torsion, so I repeated for torsion. These are the questions. 5 questions are only given, but you don't have to do all questions. See how it is. The instruction is like this. It is very simple assignment, but it can help you to a lot. When you talk, when you present, you are learning a lot. You are insisting on reinforcing your knowledge. It will be very helpful to get confidence in the subject. Right. The total marks 20%. Giving you the brief today. Oral presentation carries 20% in terms of video submission. You're going to submit a video. It can be, and let me give you the details as follows. An assignment tab will be sent to you. So I will post this assignment brief in the assignment tab in the MS Team. You can create the video on the problem that was given to you. It may be analysis or evaluation or both. It depends on the question. And then no separate presentation is required. Actually, I wanted to conduct in the class. If you are interested, we can conduct it in the class. But I feel better you take your own time to do it. I don't want to disturb the class time. We have plenty of things to do, right? So you do at your own time and then compile this video, submit it. The video should be short with a clear content, good quality picture, voice of your presentation, no background music. Sometimes they decorate, no decoration required, no background music required, and sounds required. Oral presentation is it's a single individual, not a group presentation. And then you will analyze what you do. You will answer the question, right? You will just answer the question in a white paper. The solution of the question assigned to you, the activities aim to facilitate the students to apply their theoretical knowledge into analysis, evaluation, and presentation by a video. It's just reinforcing your knowledge and skills obtained. That's it. That's why I see the repeating. You already do it in test 1 and also in test 2. Third type of assessment is for you to make the video. To enhance the development of knowledge and the skills identified for set course, the video is selected for the students. You must prepare and conduct a video recording yourself. A script under, how do you prepare the video? You must have a script first, right? And right now I say either you work out the solution and then go through the solution according to these steps, or you open up a whiteboard, use your pen, right, the stylish pen or any pen, you start writing and explaining when you are recording. Both ways is acceptable, but the complete solution should be shown, right? It's assignment work, written work. In addition to that, you are presenting written work. I have to see clearly all the steps. How do you write the script? Whenever there's a video, there should be a script, right? How to start, what is the first line, second line, what's the dialogue, where to start, where to end, where to give another add video or something like that. A script under smart headings such as strategy, modeling, analysis, it reflect. Remember the very beginning of the module, I introduced this one for you to learn how you present your answers. Please follow the same thing, right, to give your answers. This will also help you to prepare the answers. Subsequently, you will need to provide a brief reflection piece to supplement the knowledge gained through this analysis and design. Marking criteria is like this. I follow exactly all through the criteria, right? The script that you are going to write, the answer you are going to present. These are the steps. What are they? I explain once again. In the beginning I have explained, but I do it once again for you so that you are clear what's the methodology you follow. Once the question is given, as usual, you start with given data, free body diagram, all these things, right? The same thing I put under different headings, subheadings, that's it. Include a clear statement of the problem, right? What is asked, what is given, right? And then specification of what is to be determined. Decide what concept apply and how they can be used to solve. Just design on the which chapter, which form, method, and so on. Then coming to model, create a separate diagram for each body showing all quantities involved, right? You must segmentize. If it is asked at pin B, then segmentize part by part. You draw and show where you are analyzing. Modeling means you separate it into part by part and then do section by section your answers. In equilibrium analysis, indicate all forces acting on all the free body diagram. The free body diagram may be full or part by part. You can show and bring out your answers in this stage. And then further, this is only drawing and development of the model. Here you solve, do the calculation, use the calculator to complete your calculation, and then don't spend a lot of time, and the time constraints also there, I will tell you later. I mean, it follows. The 6 fundamental principles are applied to express the conditions of rest or motion of each body. The rules of algebra are applied to solve the equations of unknown quantity. It depends whether you are applying algebra or the equation that is already derived, like just now we show for Mohr circle. Whatever the equation that is applicable, you have to adapt and solve them. Reflect. Based after solving, after getting the answer, just reflect on the answer just now I explained. Test for the errors by verifying that units of the computer results are correct. Test for the errors by substituting given data computed results into previous unused equations. You don't have to go this much, but this is how the testing is done. In your case, you just read, right? The same question, similar question you would have done in the class or in the assignment. Just compare between, right? Or otherwise, just theoretically say what are the relationship between the parameters. What if it is increasing? What is decreasing? How economic? How you can make this design economic? If it is a design, if it is analysis, how I mean material. You can also supplement with the material. Some kind of discussion in 2 lines, just 2 lines enough. And then always apply experience and physical intuition to assess whether results seem reasonable. Yeah, that is always there. Once you get the result, you don't just blindly stop. Compare between work back and check whether your answer is reasonable, and then any alternates can be provided, right? Also, you can discuss at this point. Or just 1 minute or 2 minutes like that. The class lectures, you can, for this purpose, you can use class notes, the tutorials given, and the videos I have shown. Today's videos also I will give you the link. It's very good animation that we cannot make. We can borrow and learn from them. Very good animation for understanding the chapters, in addition to classes and other materials I'm giving. So by week 13, you have to submit the video. Some more instruction about the, any questions so far? Okay.
Miss,
Yeah.
so the 5 questions, right? We also need to submit the 5 solutions, right?
No. That is what I'm going to explain now. Yeah. Give me a minute. Any other question from the based on the previous discussion? Right. Not all. Let me go through this. You will know. Create a learning video by using any online platform screens. How do you record it? You can use screen recorder, OBS, Screencast-O-Matic, Microsoft Team, or any media. Even nowadays, by PowerPoint, you can record. You just go through YouTube videos. It will help you how to record using PowerPoint. It's very simple. But going back is tedious. Mind this point. We cannot go back and check. It's not so conducive. But anyway, you can try any of them. A screen record also very simple. You can just keep doing it. Borrow the software and then do it. All available free. This is also, screen record is available free for 15 minutes, I think, free. And another one, camcorder also there. You can make use of them. Okay, assignment brief has 5 questions. You must choose one only, per person one only. You need to answer all of them because you're spending time for preparing video. If you are interested, you solve and keep it with you. But for submission, you have to give me only one. One in the form of video presentation. You may choose one question from the section 3. Based on the last digit of your student ID. Which question you will choose? To avoid plagiarism or copying anything, I introduced this one. You have to choose based on the ID. If the ID ends with from 0 to 1, then you must choose the first question. 2 to 4, second question. 5 to 6, third question, and so on until it is 9, fifth question. Alright? One question only. Which question you choose, the procedure is given here. Please follow the sorting method. Otherwise, this is a random, so that you have a random pick. Right? You must record while you solve the question or complete the calculation and present it. Also fine. Present from the beginning to end, following those strategies. 4 strategies that was given to you, the steps given to you, and also I've taken the same thing for my marking. Kind of solution wording. In both ways, you must cover the marking criteria set above for the assessment purpose. Okay, come on. The duration. I said 5 to 7 minutes. That's it. That is all very high. If you want, we can reduce it or increase it. You suggest to me, or you try and tell me. Now I think 5 to 7 minutes are good enough for one question, because if you're worked out, you're going through that. If you're going to work out also, you please practice to solve like that, right? Okay, long but no longer than 7 minutes, right? No longer than 7 minutes. Maximum 15 minutes, I tell you, but not required. If you are familiar with all the topics, you can quickly go through and work out one by one. Provide a self-reflection at least for 2 minutes in the video describing your outcome and knowledge gained by the calculation. You can also share your own experience about your question solved. Imagine you are a site engineer, you're going to fix that particular member and how you're going to address this issue, right? So then that type of reflection is also very good. You can submit the completed video to the same tab where you have downloaded your assignment question. You don't have to submit to me the workout, and no need, it is already there in the video. Don't duplicate the information. You just submit the video with the workout. I mean, no need to work out. Just submit the video only. Sometimes the students ask, can I submit the workout? If you are interested to check with me, you can post in your notebook. Our communication is through notebook. If you want, I can correct. But don't, no need for formal submission. Just submit the video only to avoid a confusion. And then conditions. Don't copy, don't discuss with it. You can, it's assignment, it's also for learning. I treat these assignment tests and all as for part of learning, right? In that case, try to do yourself. If not, you can ask me, but avoid copying from others or textbook or any other. Please strictly avoid it. I'm here to help you. You can ask me anytime. So for this one is done. Submit only through the MS Team under assignment tab. Don't go for any other submission. I'm sure I'm giving the video memory. Okay, you can see the file. Now coming in. Submit through the MS Team. Okay, don't use any other format. That same tab you use it to submit back the assignment so that I can download as a one stretch. Anything? The questions, I will go through the question if you want. It's like an exam question, no, don't worry. It's a good practice for you to solve one, get confidence. Number 1 is on finding shear stress and bending stress. If asked, you do it. If not asked, you just answer for the question only. Maximum shear stress, and next one is you have to determine the shear stress when the value is changing, the diameter is changing. And then the third question on design section is given to you. You work out all the answers, come out with the best section. The best section you can find from this one, this table. The grade is given. So based on the properties that you determine, you'll be choosing from this table. Right. What else? So last one on one line you will use that table, and then this one. Base stress, normal stresses, right? Normal stresses. It is also we are solved already. And last one is a torsion. Maximum shear stress, just a shear stress one, very simple question. You know who is the lucky person to get this question? Maximum, just find the shear stress only. Very simple question. Okay, with that, I think over. Some of them, I think what you call formulas are also given to you. So like this, today we gone through. This one is not required. I'm not giving you stress. Last time I gave.
Miss,
Yeah.
I have question. Do we have to show ourselves in the video or just handwriting?
Have to. That's why I said camera should be on all through the presentation. Please practice like that because I do not know who is presenting otherwise. You see.
So I have to show myself and also the whiteboard at the same time.
Yes. You must show
Okay.
your face, your slide.
Can I show myself in the beginning of the video and just record?
Okay, okay, no problem.
Because during the presentation, if I open the camera, I think there will be an interruption.
Okay, okay. But at least in between it is a testing, right? I mean, I have to
Okay.
evaluate that uh, who is doing, right? The person who is doing. So then, beginning, as you said, the beginning and last, you can show the face. Hmm? Right. Any other question? Hope you will enjoy this assignment. Anywhere you stuck up, you ask me. And I'm going to solve. Today. No, that day. Hmm, Martin, I think Martin asked one question, but you check with me. I mean, I want to check with you whether you also have the same question. Did you try to solve the questions on bending one shear force or no? Did you try? Let me open the question. You have any question on that? Can you solve all of them?
Yeah, can. No question already.
Oh, very good. Huh? You tried already. You solved. Huh? No need. Huh? Okay. La. If I mean, any other, I think he solved already. Because you work from the right or left, I'm sure you will get it. I have already explained few questions before. Use the same procedure, anti-clockwise, clockwise, all these things you follow, you will get it. Right. Any other question not clear, Martin? All others you have done already, right?
No question.
Okay. Right. Anybody else have any questions on the question bank? Please keep solving all of them, right? Let me continue with the class. When was the test due date? Right. When the test due date I already proposed, right? 20. Can we have it on Friday 30? July 30? Because you're already doing another assessment and no need to overload too much.
Can.
Okay. I will propose, I will confirm the date and then post in the chat box. We can have it on 30, right? If no question, let me continue with the Moore circle plotting. But next time when you bring the graph, right, everyone have to draw. You bring the graph and work along with that. I try to complete, otherwise I don't think can be finished within half an hour. Will be anyway half the way. After the class, you go on and solve this and bring it for the next class to continue, okay? Let me open the file. This is a graphical analysis, so you must use a graph. If asked in the exam also, will provide you a graph, but now you have to choose yourself if you are doing it online. One question, one graph. And don't write any other thing onto the paper. I see people working on the paper, graph paper. Don't do any calculation on the graph paper. Do it on the other papers. Graph paper is meant for the circle only, drawing circle and its values. Where is the file? If you have any question, you can ask me. Transformational stresses. Right. Okay. This one, more circle. Give me a minute. We had introduction about how to get the translated form of stresses depending on the different orientations. Some video I've shown how the values of stresses on a body, stress development on the body, it may be normal stress in the form of tensile or compression, or otherwise shear stress. Both keep changing when you keep changing the angle of rotation. When the body is in rotation, body is in movement, the stress concentration values will also get changed. It is balanced between normal stresses and shear stresses. And there will be a point, crucial point for engineers at which it will fail. The system will fail. System will tend to fail. All these things we have studied in the theory in the last class and the previous class. Through the slides, I've explained both examples and the failure modes, everything. Now, this is the method of getting the translated stress values so that one can aware of at the failure point up to which you can design, above which it is not able to withstand the stress on it. So we have to monitor the development of the stress while loading a member. At what point it will fail, then stop loading. That determines the design value of your component design. Component may be a screw, maybe a fringe, maybe a pipe, maybe a connection, or any type of elemental body or the main body itself. Mohr circle is the graphical representation of or graphical analysis of getting your transformed values of stresses and strain at a point on an element. The element can be taken from any section of a member. Here I'm going to give you a few examples. There are 5 examples already worked out in the slides. Please go through all of them. It'll be interesting to thorough the different conditions of under which it is subjected to and the corresponding development of the principal planes and their stresses. It is difficult to understand, but once you understood, such an easy topic for you. Just 4-line answer. Giving 4-line answer, you are getting 20 marks already, right? But understanding takes longer. You must understand the crux of it. Remember the notations, remember the convention, remember the rules set, the procedure that you have to undergo. Just 4 steps only involved. Okay, let me start with this. The given data for each of the plane, number one question says, for each of the plane stress states listed below, draw a Mohr circle diagram and determine the principal stresses in the plane. Okay, the stresses given are, number one is given as normal stress. Number one, normal stress is given. I will type it down. The question is given as normal stress. Normal stress. Normal stress is a given value of sigma x is equal to 20 megapascal. I write here B is equal to, B is normal stress sigma x, and then another normal stress or axial stress, also you can use that word, in y direction is equal to y direction, sigma, this one is sigma, y direction is equal to 10 megapascals, and shear stress, C is shear stress, the value of shear stress, tau xy plane is equal to calculation. The next you have to follow the strategy. Started with strategy. Strategy will say what are the principles, what are the equations you're going to follow. Second will be modeling and analysis. You subject these equations, find out the answers, step answers. All steps are important. Please make note, each and every step is evaluated, having mark. You should not leave any one step. You must show a detailed workout. Don't leave any line, then you are leaving your mark. Don't skip any line. Give all the detailed steps of solving this problem. Each and every step is marked. It is not that for final answer is marked. It is marked for each and every step. Sometimes you say, I got the answer, I didn't get full mark because your steps are not there. Complete steps are not there. You have to give the complete steps of solving the problem. Next solution is equations we can take from, I will provide in, if asked the exam, I will provide in the formula sheet, but that they are not going to be helpful. That is only guideline. You need to solve Mohr circle to find out this answer. The solution is by drawing the free body diagram or given plane. Sometimes the plane is given, or you have to draw like this. The given plane is like this. Box, right? An element at this point. Normal stress at this point is how much? 10 megapascals. So it should be contracted by this other direction. Then it is stable. According to the equilibrium condition in any body, if there is a force, then should be a equal and opposite. That is why I put another arrow here. And this value is given in x direction. 20 megapascal is acting. And then also you are given with a shear stress acting downward, which is 8 megapascals. Okay. And for this counterpart will be again like this. And this counterpart, when this is acting like this, it will turn this surface to move in this way. Okay. It will move the surface in this direction. Okay. It will tend to move the surface in this direction. So these are the directions of force. Stress. Given stress I marked on the element. It can be a point or an element of it on the body, okay, on a solid body at any section. These are the given stresses. We are going to find out the principal stresses. Principal stresses are the maximum and minimum stresses, or range between minima, average, and maxima. Once you know all these things, you can conveniently design your component. You can apply, you can put into use, you can practice it, and you may know, as an engineer, you may know when it is going to fatigue, when it is going to fail, when it is going to bend, when it is going to collapse totally. That is the purpose of knowing this maximum, minimum, and average, or it's called a range of stresses on this body, acting on this body. Right? That could be conveniently found by Mohr circle. It's a repeat graphical analysis. When I say graphical analysis, you should know how to draw graphics. Okay, use graphics. Okay. Second The very first step in your solution is, sometimes it's given, if not you draw this free-body diagram, and then second will be to find average stress. Your Mohr circle starts with finding average stress. All these equations are there in the formula sheet. Generally speaking, average stress. See, all of you know that whenever a body is subjected to loading, remember the video I shown last time, it is subjected to compression, tension, right, in the axial direction, and shear along the surfaces or end surfaces, isn't it? Hence, when you to get the average stresses acting on this body, here you see it's a kind of a tensile force, right, acting outward. Because the arrow is acting outward, it is tensile stress, okay? And then if you see here, can you use this? If you see here, this is inward compressive. In this direction, y direction it is compression, x direction it is in tension, right? And you should remember the sign convention. You need to write down the sign convention, everything. But I write down the sign convention. You remember, you don't need to write, but for few questions better you write down the sign convention. Sign convention, we take it like this, okay? Please remember carefully, apply without any error, okay? Right, number one, starting here, clockwise rotation, positive, as usual, clockwise, remember the clockwise direction I teach you last time, clockwise, positive, anti-clockwise, negative, okay? Remember this sign convention, you can solve correctly, right? And then because it's compression here, you must take it as a negative component, right? Let's find out the average. You need to find the average stress acting on it first of all to start your Mohr circle. Mohr circle keeps the average as the center point of the Mohr circle. So it started with the center point. You can draw the circle. Started with average. Average is between, the formula for average is sigma x plus sigma y divided by 2. The answer here is sigma x. You do algebraically, better you write down then and there what is the nature of this solution. When I say algebraic, the sign is important. When I say arithmetic, algebraic means when I write, sign is included. Arithmetic is numbers, only numbers. We don't bother about the sign convention here. No sign, I just put no sign. No sign, consider. No sign, consider. When I say arithmetic means, okay. Now, sigma x is positive. Tension is positive, right? Going outward is tension positive, so 20 positive. And then sigma y is compression, negative. 10 divided by 2 will be 5 megapascal. Okay, we got one answer. The third step will be to draw the circle. Okay, care should be taken. It will take few minutes to draw it. You have to understand it carefully, right? Let me start here. I do graphically, you keeping scale, okay? Each one is taken as, because one hardly it is 5, 10 like that, right? I keep the scale is the scale. Whenever you do graphical, you must keep the scale. Scale is 1 block or 1 centimeter is equal to how much? 5 megapascal. I keep it like this. Or 1 box. Here 1 box. 1 centimeter is 1 box for me. Box. 1 centimeter or 1 box. Box is equal to 5 megapascals. Let's plot the coordinate system. For this, I insert the lines here. Insert the line. All of you start drawing in your graph sheet. Keep the scale and start drawing together with me. Or wait for me, let me finish, then you do it. Okay. And then name it. You can take the x-axis as your sigma, right? X-axis as your sigma. I use the red color. Sigma, this is positive. sigma negative in this direction, tau positive, tau negative. Okay, I take the normal stresses on the guys, can you hear me? I just want to know whether you studied this Mohr circle before in your soil mechanics or laboratory or in any geotechnical paper?
Yes.
Oh, you already know how to plot it, isn't it? Okay, very good. Okay. I do one question, the second question you can do yourself, but you ask me if there's any problem. X-axis, shear stresses on the y-axis, and also I put the sign convention as it is in the graphical domain. This is positive, negative, negative, positive, right? And then start with center. As I told you, the center of the circle started with average value of the stress existing here, 5 megapascal positive. So I keep this as so 5, 10, 15, 20, for 5, 10, 15, 20, 25, 30, like that. So my 5 will be lying here. This is my center, okay? With this, I have to mark the next stress given to me. The stress sigma x is how much? 20 megapascals, okay? So 20 megapascals is from here is and then moving on, let's mark the value of shear stress. That will give me the boundary for my diagram, your Mohr's diagram. Start with your shear stress is how much? 8. Is it positive or negative? To find positive or negative, please understand the arrow given is like this. Okay, arrow is downward. When you say here, arrow is downward, keep the you keep the clock like this. Keep the clock like this. I have to remove 12, 3, 6, 9. Keep the clock like this. It is downward, right? The direction is downward. So it is clockwise direction. So positive. Okay. I remove all these things because I don't want this unnecessary thing sitting here. Hope you understood the clockwise. Why I take the clockwise? It is in the direction. The direction given is in the direction of clockwise. The direction shown on the diagram of the plane stress given to you is downward 8 megapascal. So I take it as positive, which is in clockwise direction. So from the point of the shear normal stress 20, you mark 8 here. This is 10, right? 5, 10. This is maybe somewhere here. This is my 8. Okay, this is my 8. So once we mark the 8, we mark here as the 8. There should be a counter value acting at this point. Or you write down this coordinate system. This coordinate system is 20, 8. 20, 8. One moment. All right. 20, what is this? Both positive, right? 20, 8, both positive. So as I said before, it has to be contracted. I mean, just mark the other value on the other side. It should be contracted by this value at the opposite direction, which is negative 8. So we mark the negative 8 for the y direction stress value. How much is negative 8? Somewhere here. 5, 10. Should be somewhere here. This is 5, this is 10. So somewhere here. Right? Now I repeat once again. We have marked the shear stresses along the xy coordinates of, because x is your shear stress, normal stress, y is your shear stress. When you make the pair of these two values and mark on the diagram here, you have two pairs. Number one is this given value. Which we marked already. And then number two, for the y value, it should be negative, because in the y direction it is negative, right? It is opposite like this. So you can mark here as the negatively, when there is a shear stress acting positive here, there should be equivalent opposite, which is 8 here along y-axis, normal stress. This determines your diagonal for the Mohr circle. Let me take the ruler. Where's the ruler? I just put the line here, insert line. All of you must do to scale. I cannot keep the scale here, that's why I'm using this one. All of you must draw to scale. You may use the graph, it's convenient for you. Hand and scale, hand and graph. I'm sure you can use this. I have joined these two lines. These 2 points that determines the diagonal, and you can see that peculiarly. You can see that it is cutting at the average. The center point is cutting at the average. Now, can we draw the circle with this diagonal? In your graph, how you do? Take this radius. Can you see my hand? Can you see? Take this radius in your compass and then keep the pointer here. Rotate the pencil around the line. You will get the circle. But in my case, I just insert because I'm doing this app. So I can only insert by a circle. I do it like this. But in your case, you have to do it by compass, using a compass. Hope you know how to use the compass. This is center, right? The point C, I mark is the C for convenient principal stresses using the Mohr circle. So number 4 is determine the principal, we construct it, and we are going to determine the principal stresses. By rule, principal stresses are lying on the x-axis or lying on the x-axis, or otherwise principal stresses are calculated when shear stress is 0, right? When shear stress is also 0, the stress produced are maximum or minimum or average, and they are all called as principal stresses are important. You can say this as a notable stresses in any phenomenon or in any material. Okay. Let's mark the equilibrium points. This point, and this point. Having done the calculations, then this point and this point is giving you the minima and maxima. We can call this a sigma minimum and sigma maximum, or 1 and 2 also you can mark. Okay, these 2 points are the sigma minima and maxima. Now, to just put the triangle, close this triangle or draw a perpendicular from this point to this. Okay, because we need this triangle for our calculation purpose. We just drop a triangle or draw a perpendicular from this point to down to cut the x-axis to determine our principal stresses. Because you have sigma minima at the edge of this circle, sigma max at the edge of this circle. Okay, let's start doing it. Before doing it, we have to find one more. Just extend this line. To get your radius. Okay, just extend along this line. Okay, wherever the triangle form, extend simply to get your unknown values. Your triangle is like this, isn't it? Your triangle is like this. Okay, that is okay. You see, and the horizontal value you should be knowing. Okay, this point starts with 5, or the value at this point is 5, correct? Value at this point is 5, and also serves as the center. Okay, this is 5 and also serves as a center, right? So my value at this point is 8. Let me erase for a while. I need this space. 15, right? 20 cut 40 is 15. And what is this one? R. Let's take this triangle and find out R, right? That should be equal, Z is equal mirror. This is R. Let's take this triangle and find out R, right? That should be our next step of doing. Before you find out the principal stresses, should be knowing your R, right? To determine principal stresses at x equal z is equal, where tau is equal to 0. The value occurs at tau is equal to 0. Or shear stress is 0. Principal stresses are maxima and minima and the average, right? Because it's all lying on the x-axis. Let's find out first our value. R is equal to, from the diagram, R is equal to square root of 8 square Pythagoras theorem. First perpendicular, right? We draw perpendicular here, so I can use the Pythagoras theorem to find R unknown, which is R square plus 15. 8 square plus 15 will be, if you solve, you will get 70 sigma max. Sigma max, I repeat once. Let's stop here. Please bring 2 graph sheets by next class. We will solve 2 questions in the class only for analyzing the normal stresses using Mohr circle. Is it okay? Any questions so far? We'll continue in next class. I have to stop here. We'll continue in next class. Any question? If no question, just remember 2 points. You have deadlines, 2 deadlines. Week 13 on 26th July, you're supposed to submit your presentation slides. On 30th of July, you have test 2, chapter 3 and chapter 4. Okay, I stop here.